Welcome to Z-Tech Almanac. Today I have a very neat project, a communications receiver that we'll be restoring. It's a Yaesu FRG-7. This receiver has a very special tuning mechanism. You have to use a band selector, then a megahertz selector, then a pre-selector, and finally the tuning knob to actually tune the receiver. So we'll go through that and see how that works. It's a great receiver if you're just getting into Morse code or single sideband. So we'll try to find some stations that are single sideband here in the area, and listen in once it's all done. Now the receiver has a couple of small cosmetic nicks, but it's looking pretty good. And so we'll be mostly looking at the electronics, and we'll see what needs to be tuned or restored inside. And we'll take it apart and take a look inside, and maybe recap it, and we'll see what we need to do. All right, let's get to it. Here's the receiver. We can see the front here. Now I've cleaned it a little bit with some alcoholic wipes just to get the dust off. But there's a couple of small areas where I'll have to go through and see what I can do. Here's a little area that that needs to be maybe painted. The case looks pretty good. There's an area here that's scratched, but I'm probably not going to do much about it. I like this color. This is a frog green color, they call it, and I want to keep it. I want to keep it the way it is, and I don't know if I can match it exactly the way it was. So, plus there's going to be a little frame that's going to go here. I took that off because that was scratched, and I will paint that. So. I'll show you that a little later. So going to the side of the case, looks pretty good. And then, on the back here, I have the screws out right now, so I kind of slipped in there. But we have a battery compartment, which is really interesting because this receiver actually works with batteries as well. External DC, external speaker, fuse, of course, the power cord, and then the confusing part here is that there's a couple of antenna connectors. This first one you'd think is the only one you need. Well, that's actually wrong. That one you need if you're wanting to receive above the broadcast band, so 1.8 megahertz and above. But if you do want to receive on the broadcast band, it's actually this connector that is specifically for the AM broadcast band that you need to connect. So once it's all done, we'll hook up a wire antenna and we'll check out the receiver that way on both bands. Obviously the broadcast band is going to have the most stations, and so we're going to use that connector for that. And then I'll connect an antenna to here to go all the way through the shortwave band. So this receiver goes from the bottom of the broadcast band, so about 500 kilohertz, to all the way up to 30 megahertz. So here we are looking at the front of the receiver. We'll have to go through all the buttons here. So on the right hand side here, there's two jacks, one for recording audio, one for your headphones. So recording audio just basically gives out a stable level of audio that you can plug into any sort of recorder or computer even. But the phones will be controlled by the volume, so you can put some headphones in there. Standard 3.5mm jacks. We got the power switch. We got the light switch, so the light will light up an incandescent light on the dials here. And then this knob here is for the mode. So we have a couple of modes here. So we have on the very bottom, we have an AM mode. And this ANL means that it has an automatic noise limiter on top of it. So noise limiter means that if there's any pops from motors and other electric devices that are generating high current and sort of RF noise, that will try to limit some of the noise. And then if I move that up here, that's a standard AM mode, without the noise limiter. And then we have lower sideband. And then we have upper sideband up here and CW operation, Morse code operation. So, once we try this out, we'll see if we can get some, USB or LSB transmitters, ham radio transmitters in the area here. They're kind of hard to find, but we'll try. This knob is self-explanatory. It's the volume here, so that's pretty standard. Now on this side we have the tone. So we have three settings: low, normal in the middle, and then narrow. And this means that on the low tone, we're gonna hear some of the lower frequencies in the audio, because the bandwidth of the receiver is wider. The normal mode is where the bandwidth is narrowed down a bit, so you're gonna hear less lower frequencies and less high frequencies of the audio. And the narrow tone is where it's super small bandwidth, and then basically it's good for speech or ham radio operation. So, and then there's an attenuation option as well that basically attenuates the front end to local stations, meaning that it's the most attenuated. So basically turns down the amplification of the front end of the receiver, and then the mid-range is for normal, and then DX for far away stations, so it's the most amplified in the DX position. Now, the next step here is to look at the tuning a little bit. So we'll kind of go through this as a dry run, but the way tuning works is that first you use the band selector switch, and there's 4 bands. The A band goes from 0.5 to 1.6 megahertz. And then B goes from 1.6 to 4.0, and so on and so forth. So you'll select that first to see what band do you want. Then you kind of have to know roughly what megahertz range you want, within plus or minus a megahertz. So basically, this receiver likes to tune within, it's easiest to tune if you know within a megahertz what frequency you want to listen to. And the next thing you do there is you say, okay, well, if I'm in the 0.5 to 1.6 megahertz, which is mostly the broadcast band, I'll tune my megahertz knob down to where it shows that it is, in the 1 megahertz range. So it's like basically between 1 and 0 here. And this basically is a kind of selector, in a sense, to select which megahertz range do we want to tune in. Now after that, I'll do my pre-selector, and this is really the front end of the receiver where we tune the antenna and the input circuitry to the right megahertz range. So here too, you want to tune it roughly, where you think you might be listening to. So if we're in band A, which is the very bottom line here, maybe we'll just tune it to 1 megahertz or something like that. And then once you found a station, then you can fine-tune this one to really tune it in there. So this basically tunes the antenna and the front end of the receiver to that station. So, and then to actually tune the receiver, you use this knob, which goes from 0, which means is that it's whatever megahertz you selected here. So in this case, it would be half megahertz to 1.6, and it goes all the way up to 1 megahertz. So basically, the range of this tuning is 1 megahertz in this megahertz selector here that we selected. So, and we can go through higher frequencies as well, where this becomes more important. So if you want, like 10 megahertz, you go on band C, you put this nicely on 10 megahertz right there, and then you pre-select that to 10 megahertz, and then your range here is gonna start at 10. So when I have it 0, it's at 10 megahertz, and it's going all the way up to 11 megahertz right there. So we'll take a look how that works, and an easy one to sort of at 10 megahertz, I choose that one. The easy one is to look at is the time signal that's being broadcast. So we'll find that and we'll listen to that and see how this all works. That's sort of the easiest one because we know it's at 10 megahertz. Okay, let's take a look inside. So the chassis is pretty simple, just the receiver just slides out. I've taken the screws out already, so there's a couple of screws here on the top, there's a few in the bottom and a few in the back, so really easy to take apart. And then once you have the screws out, all you have to do is you just slide it out, and hopefully it'll come out nicely right there. So here we are inside take a look inside the receiver. As you can see here, what we have here is the two boards. So this is the RF board. So this is where the antenna is connecting to, and signals coming in, and amplifications happening, and the IF section is the intermediate frequency section is there. And then the RF board is hooked to these tuning capacitors. So these are hooked to the megahertz selector that I showed you in the front panel, and then the pre-selector, which is this one. And then finally we have the fine-tuning dial here, and then that's hooked to another capacitor down there, a variable capacitor. So that's the RF section, the RF board. And then on this end of the receiver, just want to make sure that it's visible, this end of the receiver, there's the audio and the power supply section. There's a little bit of RF, so there's IF frequency transformers here, you can see there. But mostly this board is doing all the audio amplification and the power supply filtering. This here is the battery compartment, and you can put in, I think it has 1, 2, 3, 4, 8 maybe D cell or C cell batteries that will power the receiver. I haven't tried it, I don't know if it works. I did hook up this receiver a little bit to power, just a little bit, just to make sure that it does power on, and it does power on. So we'll see that pretty soon here. But I haven't tested it with those batteries. So going on the other side, just taking a look on the other side here. So on this side, we just see the back of the receiver, the back of the boards, and there's nothing too interesting here. There's the power transformer, so the power coming in from the mains here, and then goes into the power supply, power regulator board here. You see this capacitor that was probably installed later, or maybe it's a factory, who knows. And then we have the RF board here, the back side of it, and you can see a couple of caps there and resistors and things like that. Now, I normally, if it works, I don't touch that, because even just the wires here are set at factory just so that the receiver is tuned exactly. And so I wouldn't even move any of these wires around, because it could actually affect the tuning at higher frequencies. So at 1 megahertz, it may not matter much or at all, but tuning at 30 megahertz, moving some of those wires could in fact shift the tuning around a little bit. So we'll check out the tuning a little later and see how well the receiver tracks in the band, and if the band edges match up. Likely they will, but we'll check that out later. Okay, a little bit of sidebar here. I want to show you the front frame here that I took off. I've tried to sand this down a little bit. It was scratched, and it didn't look good at all. And then I painted over it, a couple of coats of painting. It looks okay. There's still, the previous owner, or a couple owners ago, I guess, they sort of scratched their name in there, and that's still a little bit visible. That's okay. It's part of the history of the receiver, so I don't mind having that there. But this basically kind of goes on like this, and once we put the whole thing together, then that will look really nice. It looks kind of nice and metallic, but not too jarring, because some of the front knobs are shiny as well, so kind of matches that silvery look of the the receiver in the front. Okay, let's turn this on and let's see if it works at all, or let's see what needs to be done with it. I hooked up a pretty small wire antenna to the AM input, and we're going to try out the upper AM band just to see if there's anything there. It is daytime here, so reception conditions on AM are pretty bad right now, but we should be able to hear something. Alright, well, let's see. So we do hear noise, which is good. It means that the oscillator is going, is working. The light here seems to be working for the dial. The dial lights are good. I'm gonna leave that on. Volume looks okay. AM versus AM with noise limiter. I think that's fine. I hear some sort of station coming in. Okay, let's start tuning. there's something there. Reduce the volume a bit. As you can hear, the sound quality is pretty bad, so for sure we'll need to take a look at what's going on. I suspect that it is the capacitors, it is the electrolytics that are gone bad or going bad. They might be leaky, or they might be physically or electrically leaky, so we'll check them out and see if that's the problem. Could also be RF issue, tuning issue as well. So it's some of these receiver, it's sometimes operator error. If the station doesn't come in right. So definitely I think this is sort of a first try tuning attempt here, and then we'll see if there's other things that help it. The tone does changes. It seems to be working. But the sound quality is pretty bad. Okay, well, let's figure out what is going on. Before we troubleshoot the receiver, let's quickly go through the block diagram here. As you can see, we start with the antenna coming in, the signal coming in, goes through the attenuator, and that's the knob on the front that I just showed you. That sets how much do we want to attenuate the signal. We have an RF amplifier, and then we go straight into the first mixer, which is coming from an oscillator that goes from 55.5 to 84.5 megahertz. And this is the megahertz set knob on the front. So when we tune that megahertz button on the front, or knob on the front, we're changing this oscillator, setting this oscillator. So first mixer goes into that, and the output of that is 55.5 to 54.5 megahertz. You realize this is a little hard to see here, but hopefully you're able to, take my word for it, if it says the right number there. Now, the interesting part of this receiver is this sort of 1 megahertz crystal oscillator that generates a whole bunch of harmonics from 3 to 32 megahertz. And all these harmonics are generated at this point. So like you can imagine that basically this just has a harmonics generator. And it goes into this premixer, and then we have a bandpass amplifier here that only lets the 52.5 megahertz harmonic through. So based on your megahertz tuning knob in the front and the harmonics of this oscillator, we can actually now set, per each megahertz, what band do we want to tune. So that's how that basically sets that 1 megahertz range of tuning range. And then out of this 52.5 megahertz, we branch off here to the detector and to a little lamp driver. It's an LED in the front that says, are we in the center of that 1 megahertz megahertz knob, right? So make sure that we're tuned correctly to be able to tune the band. Okay, so second mixer is we have a 55.5 and 54.5 megahertz signal coming in, plus or minus rather a 52.5 megahertz signal going in as well. So out of that we get 2 to 3 megahertz range of 3 to 2 megahertz. So basically we're down to that 1 megahertz range required for the fine tuning knob. And so the fine tuning knob is this capacitor here, and it's connected to this VFO oscillator, and the frequency for that is 2455 kilohertz to 3455 kilohertz. And so mix that together with the 3 to 2 megahertz incoming signal, and we get our sort of classic 455 kilohertz IF. So that's our third IF frequency. And so that one now goes through a ceramic filter here. This is I think a narrow filter. I think it's plus or minus 3 kilohertz. And we have a detector, and we have our noise limiter here, the automatic noise limiter that we can turn on and off. And then we have our tone control. So remember that button on the front that changes the tone from narrow to normal to low? So that all's happening here. So that the tone in the manual says that for normal, the tone basically frequency range of audio is set to 250 to 3000 hertz. So roughly speech range. For a narrow tone, we are at 400 hertz to 2500 hertz. So a little bit narrower, so the lower frequencies are cut off. And for the low setting on the switch, it's 250 hertz to 1500 hertz. So it's actually cutting off the high end on that one. So it's just a matter of fine-tuning, the tone of the audio there. And then finally, we have an automatic gain control circuit here that is coming off this IF chain here, and it's applying, and it's connected to the S meter on the front. So that's quickly the block schematic before we dive into the real schematic here. And just for fun, here is the schematic. Now you can see that it's quite involved, so we're not going to be going through all of it, or even some of it, but I will zoom into a couple of parts here that are sort of simple and interesting to talk about, because you might have to figure out issues in those areas. So I'll just zoom on in here in a sec, and we'll kind of discuss a couple of interesting blocks, I guess, on the schematic. We're zoomed in here a little bit to the RF section. The one interesting sort of block that is kind of core to this receiver is this 1 megahertz crystal oscillator. This is sort of the uniqueness of this receiver, where it generates that 1 megahertz signal, and then it uses its harmonics to create a 3 to 32 megahertz signal. And that is one of the buttons on the front where you select that megahertz, the 1 megahertz range that you want to tune to. So that's in this little section here. And this other section is our variable oscillator unit that is it's fed into the first mixel, so that high frequency, that 50 to 80 megahertz oscillator, that's there. Here's a closer look of the oscillator unit that we talked about, and the variable oscillator unit and the crystal oscillator unit that we talked about. Just moving over here to the right, this is where the AC comes in, and that's the AC transformer. And we see here that it's 10.5 volts on one end and 10.5 volts on the other end. That's producing AC, and that's going into the sort of the audio power supply board that we've seen in the unit. So we'll just move over there to that board in a sec here. So on this side here, we looked at the transformer coming in, and it's being rectified here and going into a pretty simple power supply voltage regulator. So this here is a Zener diode based regulator, and this transistor is the pass transistor for the power supply. And so we see some pretty big capacitors here, like the 1000 microfarads. Those are the big capacitors on the board that we've seen earlier. So that's pretty simple, the power supply. That's an area to check, of course, for any problems there. And the upper section of schematic is the 455 kilohertz IF filtering and decoding section, and some of the AGC stuff is there as well. But here on the right hand side, it's the audio amplifier IC. And so this one is that like basically all-in-one chip that is that has a heatsink on it. And so that too has a whole bunch of capacitors around it, so that's another suspect area of some of these capacitors may be going bad and could be causing audio distortion. Of course, this chip could be also going bad as well, so maybe you have to replace the whole thing. And then finally, all the way to the right hand side here, the audio output goes to the speaker or the phone jack. So that's basically it in a nutshell. So as I said before, we'll start troubleshooting sort of going backwards from the audio output through this IC and then through this section on this board basically, and see what's going on, and see if we can figure out why is the receiver sounding bad. Here we are trying to troubleshoot the problem with this radio. Previously we heard the audio is pretty rough. It's like it has an oscillation on top of it. And we can hear it a little bit here, although it's less pronounced. It's a little later in the day, so the broadcast band is a little stronger. It's coming in a little stronger. So one thing I thought I would do is use headphones to figure out if it's the audio amplifier that's the problem or the RF stages, ahead of it. So I'm just basically, you can't see or hear the headphones, but basically using headphones to figure out, if I can hear something, hear the same noise, past the audio amplifier. And so if I plug it into the record jack here, that's actually tapped off before the audio amplifier in the circuit. And there the audio is much cleaner, as I can hear in the headphones. So that kind of leads me to believe is that, there's either not too much ripple current, because this sounds like a little bit like a 60 hertz regulation issue potentially that's on top of the audio, or the audio amplifier just has a lot of distortion, potentially by design. But I kind of refuse to believe it's by design like this. So what I will do is I'll show you real quick the schematic of what I'm talking about here. But I think the problem is narrowing down to the audio amplifier, and what potential solution is measuring what is the ripple current on the power supply and see if that filters into the audio, and if that's causing the issue. At the schematic, and the area of interest here when we're testing the final audio amplifier stage is this phone jack. So I put the phones in the phone jack. As you can see, this is connected directly to the output of the amplifier, which is coming from pin 1 and going out to the speaker or the phone jack. So there I can hear basically the same thing that I hear on a speaker, that is kind of that distorted audio. On the other jack, which is the record jack here, is actually goes through this resistor, and it goes all the way up here to the top pin of this volume knob, right? So the volume potentiometer is right here, meaning that it's tapping the audio from the input of the amplifier. So the input of the amplifier comes off in the middle of the potentiometer. Basically the wiper of the potentiometer comes through here, through this resistor, and goes in here to pin 7. So that's the input. And so I can basically with just plugging in headphones into the record jack, which is, it is quiet. It's not a high voltage there. I think it's 50 millivolts. I can hear the difference of the audio going into the amplifier versus the audio coming out of the amplifier. And this audio has just less noise and less ripple on it than this audio. So, you can see there's a lot of capacitors here that are, part of the amplifier and also filtering, right? So, going over here to the power supply, we have a bunch of big capacitors here, 1000 microfarad capacitors. And, if those are leaky, electrically leaky or physically leaky, they're going to be filtering, less than they should have, when this was designed. So an idea here is to measure the ripple current there and see if that's reasonable or not. But regardless of that, I probably will recap this audio section here, just the caps over here, because this radio is pretty old. It's even if it's only 20 years old, it's worth recapping. Capacitors, even the best ones, after 20 or 30 years, they tend to start losing their performance one way or the other. So it's either series resistance, parallel resistance, physical leakage. There's just so many ways that they go bad, electrolytics at least. The other capacitors are fine, like ceramic, and all those capacitors in this radio are perfectly fine. But it's not worth messing with old capacitors and trying to reform them or do anything else. And I might just go through and recap everything, and starting with these big power supply filtering capacitors there. Well, we reached the end of part 1 of this two-part series of the Yeesu FRG-7 receiver restoration. In part 2, we'll focus on recapping and actually fixing the receiver, and we'll test it out and see if it actually works. And then we'll check out the AM and shortwave tuning capabilities, and we'll hopefully listen into some stations. And we'll talk about how the tuning works, and we'll see how well it receives, especially on DX conditions. And so we'll look at all those things. Thanks for watching part 1, and stay tuned for part 2.